When we talk about the benefits of cooking vegetables, the conversation often revolves around flavor, texture, or convenience. But beneath all that lies something far more fundamental: plant cell walls. These microscopic structures are the unsung gatekeepers of plant nutrition. They determine how much of a vegetable's nutrients are locked away and how much becomes available to the human body. Understanding how heat affects these cell walls gives us crucial insight into why cooking some vegetables doesn't just change their taste, but actually makes them healthier. Plant cells are surrounded by rigid walls made primarily of cellulose, hemicellulose, and lignin, tough, fibrous materials designed to provide structure and protection. These compounds are not easily broken down by human digestive enzymes. That means many of the nutrients inside these cells, like antioxidants, minerals, and certain vitamins, remain partially inaccessible when we eat them raw. Unlike animals, whose cells are bound by soft membranes, plants have evolved this stiff outer architecture to resist pests, physical damage, and dehydration. But it's precisely this architecture that can limit our nutrient absorption. This is where cooking comes in. Applying heat to vegetables, especially through moist methods like steaming or simmering, begins to soften and break down the structural integrity of the plant cell walls. As these walls disintegrate, trapped nutrients are freed, allowing our digestive systems to absorb them more efficiently. In many cases, this transformation significantly boosts the bioavailability of key compounds. One of the best-known examples of this is lycopene, the deep red antioxidant found in tomatoes. Lycopene resides within the plastids of tomato cells, and in its raw form, it's often bound tightly within these structures, protected by layers of cell wall material. When tomatoes are cooked, whether simmered into a sauce, roasted, or even microwaved, the heat breaks down the cell walls and allows lycopene to become more chemically available. In fact, studies have shown that cooked tomato products can offer up to 3 times more absorbable lycopene than raw tomatoes. Lycopene is linked to a reduced risk of prostate cancer, heart disease, and inflammation, making this transformation more than just a culinary bonus. It's a biological advantage. The same is true for beta-carotene, the orange pigment found in carrots, sweet potatoes, and winter squash. Beta-carotene is a fat-soluble antioxidant that the body converts into vitamin A, critical for vision, immune function, and skin health. In raw carrots, much of the beta-carotene is encapsulated within the cell matrix, resistant to digestion. Cooking breaks open these cells, releasing beta-carotene and making it more accessible for absorption, especially when consumed with a small amount of dietary fat, like olive oil or avocado. Spinach offers another fascinating case. While raw spinach is rich in folate and vitamin C, it also contains high levels of oxalates, compounds that bind minerals like iron and calcium, reducing their bioavailability. Cooking spinach reduces these oxalates dramatically. The heat not only softens the leaf structure, but also deactivates compounds that would otherwise block mineral absorption. The result? Cooked spinach delivers more usable iron and calcium to the body, even if a small amount of vitamin C is lost in the process. Broccoli and its cruciferous cousins like kale, Brussels sprouts, and cabbage also benefit from this process, but here, the story is a bit more delicate. These vegetables contain glucosinolates, sulfur-rich compounds that are precursors to cancer-fighting isothiocyanates. These compounds become more available when plant cell walls are broken down, but they are also somewhat heat-sensitive. The key is to strike a balance. Lightly steaming broccoli, for instance, breaks the cell walls just enough to release these compounds without completely degrading them. Overcooking can do more harm than good, but gentle cooking unlocks much of broccoli's cancer-fighting potential. Mushrooms are another example where cell structure plays a critical role. Their chitin-rich walls, chitin is similar to the exoskeleton of insects, are indigestible when raw. Heat breaks these down, releasing powerful antioxidants like ergothioneine and glutathione. These compounds have been associated with cellular protection and longevity, yet they're largely locked away in raw mushrooms, making cooking not only safer, but more beneficial. Even the humble onion demonstrates this phenomenon. In raw onions, many of the beneficial sulfur compounds are trapped inside tough layers of cells. Cooking softens those layers and allows these compounds to develop and release, often transforming into different, equally health-supportive forms during the heating process. This is one reason caramelized onions are more than just delicious, they're delivering nutrition in a more bioavailable form. Ultimately, this cellular breakdown caused by heat doesn't destroy food, it unlocks it. Of course, not all vegetables benefit equally from cooking. Vitamin C, for instance, is fragile and easily degraded by prolonged exposure to heat and water. That's why waterless cooking methods like roasting, steaming, or microwaving are often preferable to boiling. But even with some loss of water-soluble vitamins, the gains in antioxidant and mineral bioavailability can outweigh the losses, especially in a varied diet that includes both raw and cooked produce. We often think of cooking as something that happens outside the body, but in many ways, it's an extension of digestion. By softening, unraveling, and breaking down the structural defenses of plants, cooking starts the process that our stomachs and intestines finish. It's a form of predigestion that allows us to extract more energy and nutrients from the food we eat. And far from being a modern convenience, it's a practice that has shaped human evolution. The ability to cook vegetables, and thereby unlock their hidden nutrition, helped early humans thrive. So when we think about cooking vegetables, it's not a question of raw versus cooked, or purity versus heat. It's about accessing nature's full nutritional potential. Plant cell walls are marvels of biological engineering, but they weren't designed with our digestion in mind. Heat, in this context, becomes an ally, turning barriers into pathways and making every bite count just a little bit more.